হয়ে গেছে। তাহলে আমি এখন কোনটা এটা কি মিনিমাইজ করে দিতে পারি? হ্যাঁ, আচ্ছা তাহলে মিনিমাইজ করে বসে দিই তো, আর এটা ফুল স্ক্রিন করে দিই। বাস শুধু সাউন্ডটা বাড়াতে দেয়।
The pipelines till the storage tanks in your refinery. So when you're talking about flow improvers, solve the problem right at the three stages: production, transportation, and storage. Okay, so what will happen with the wax position problem? As I said, it will entangle the whole pipeline, the wax would be deposited, and there will be decrease in pipeline cross-section area. Obviously, there would be increase in capital investment. For that, since there will be more drag forces, your viscosity has increased, that means you require more pressure to flow this crude oil. That would place additional strain on your pumps and your economy. So, and there is loss of production due to complete blockage of pipes. As I said, the inner wall, the pipeline would be covered with the wax. It would become difficult for the crude oil to pass through the pipeline. So paraffin, which are the major constituent of this wax, they can deposit when there is slightly condition change in equilibrium. Let it be pressure, let it be temperature, or due to temperature may be loss of solubility of this wax. For normal crude oil, it is soluble. When the temperature is reduced, the wax would come out. Now, this is the problem. As we could understand the problem, there is transportation of crude oil, there is deposition of wax, and because of which there is more strain on pumps and it becomes difficult for transportation. Let's come to the solution part. What could be done? So, removal of wax deposit comes under basically three main categories: mechanical, chemical, and thermal. So when we talk about the flow improvers, as the name suggests, it comes under the second category, which is chemical. Okay. So we first go through all the three methods and afterwards come to the flow improvers. What are these flow improvers? So when you talk about prevention and mitigation solution, first one is mechanical method, which is pigging. I'll describe by figure what do you mean by pigging and how it takes place. Then there are chemical methods. In chemical methods, we do have flow improvers. Then there are surfactants. And in the last one, we have thermal methods, where we are applying temperature so that the wax remains soluble within the crude oil, either by using a solvent or by electrical heating. We'll also see in the further slides why chemical method is better, why flow improvers are better if there are more than three methods or three categories to solve the problem, why chemical is the best one. Okay, so whenever we design a pipeline, whenever we design a storage tank, whenever we design a production tubing to produce crude oil, we need to determine or do the basic characterization of the crude oil we are handling. What are these basic characterization? We need to know what is the percentage of wax content. When you talk about India, Indian crude oil is medium waxy crude oil. Medium waxy crude oil, what do you mean by that? The wax content is somewhere between 10% to 18%. When you talk about pour point, the pour point is somewhere between 22 degrees Celsius to 30 degrees Celsius, which is quite high. So when you are transporting from one place to another, whenever you will reach this temperature, if there is no other method applied, let it be thermal, mechanical or chemical, you will face this pipeline blockage problem. So let's start with the chemical method, with the solutions. So if what you could see in the figure is known as a pig, P-I-G, pig. Pig is a mechanical tool. What does it do? It is installed on the upstream and retrieved downstream. Upstream means where the pipeline starts, downstream means where the pipeline ends. A very difficult operation. What does this pig do? If you could see, there are metallic brushes in it. Like it will flow, it will move inside the pipeline and it will clear the blockages by moving continuously. the problem with it. It might be harmful to the workforce there, and it might also ruin the inner pipeline, inner walls of your pipeline when the pig is moving quite fast. So this is the disadvantage of the mechanical method. Also, it is not possible to install or retrieve a pig everywhere, sorry, at every condition. The next would be there could be thermal methods, electric heating. As there are many physicists who have joined, I would like to say that fiber optics play a role here. So when you talk about thermal heating, what we do, we use polyurethane. First we do the heating with the wires, and then we use insulators such as polyurethane for insulating the pipelines. So we are increasing the temperature above the pour point, and then we are insulating the pipeline, so there is no dissipation of heat outwards. This thermal method, it has an application in India also in Mangla field. The whole pipeline is somewhere around above 600 kilometers. For 300 kilometers, it is occupied by Kane India Energy. They have used the thermal insulation, but the problem is it is very, very costly. Where fiber optics plays a part, we can have a fire optics wire as compared to copper wires, because we can easily detect temperature is changing. The data fetching is easier with fiber optics as compared to conventional wires. Okay. In thermal methods, the next one is use of solvent. What are these solvents? These solvents are BTX, benzene, toluene, xylene. What happens in BTX? These paraffins get dissolved. So what you are doing, which is coming out at 4-point temperature, you are again making it soluble. But again, you require a little heat treatment with these solvents also. So that's the thing that is for thermal methods and mechanical methods. Next, the chemicals. If first we discuss surfactants. So surfactants are also used. So they, as we know, they have two parts. The process is similar as removing the dirt from your clothes. There are two parts, polar head group. One is hydrophilic attached to water, and one is lipophilic attached to carbon or wax, you say. So when they are attached to two different things, it would be easier to not form these paraffin agglomerates. The paraffins, which are the major constituents of the wax, they won't be allowed to agglomerate together, and it will break it up. One group will be attached to water. I'll again reiterate that for all kinds of crude oil, whenever we produce at the GGS, it contains some amount of water. Whenever we produce at the group gathering station, there is always presence of water in it. We separate afterwards. So in those, there is always water, and in surfactants, we have a polar head group, hydrophilic attached to water, and a lipophilic group attached to the wax. Because of this adhesion and cohesion forces, the paraxes are not allowed to agglomerate or to come together. Okay. Now we have seen the problem. We have seen the categories of the solution. Next category in chemical is using polymeric 4-point depressants or the flow improvers. Flow improvers means anything which could decrease the increased viscosity or reduce the drag force or makes the transportation easier. So these are basically the polymers designed to stop this agglomeration of paraffins or to control the wax formation when there is lower pour point. That means you are increasing the pour point to a higher level, okay, and they improve low temperature performance. Now, when we talk about chemical methods, there were solvents, okay, then there were solvents, and there were surfactants. Why PPT then? Why these flow improvers then? The best advantage of these flow improvers are they are relatively cheap as compared to thermally insulating and heating a pipeline which runs for thousands of kilometers. It is much easier to use a PPD, polymeric 4-point depressant. Why? They are added in parts per million in ppm level. So the amount of concentration is lowest for any of the chemical methods. Let it be solvent, let it be surfactant in PPDs or polymeric 4-point depressant. The second advantage is variable dosage. Variable dosage means for whatever kind of crude oil, we'll decide or we'll design the 4-point depressants accordingly. As I said earlier also, whenever you are designing a storage tank, a pipeline, a production tubing, we need to keep in mind what kind of crude oil we are handling. So characterization of crude oil becomes very important. So for flow improvers also, we need to have the whole data or whole characterization of crude oil. Let it be gravity, let it be wax content, let it be SARA analysis, that is saturate, aspartines, resins, etc. So when we talk about chemical structure of 4-point depressants, there are two parts. If you could see, there is a non-polar and a polar entity. In the paraffin-like part or the non-polar part, it co-crystallizes with the wax crystals, this part. It contains of carbon chain. And the polar part, it hinders the co-crystallization process. What did we understand? In the chemical structure of the 4-point depressants, there are two parts. One is non-polar, which co-crystallizes with the wax crystal, and a polar part which creates hindrance. Let's see how. So when you talk about the mechanism of 4-point depressants, we'll see that the green part is the polar part, red part is the non-polar part, and this blue portion, these are the wax crystal. What is our objective? These wax crystals shouldn't come together. These paraffins should not come together. We have to create a hindrance in between so that they could disperse within the crude oil. Either you do it by heating or either you do it by chemical method. In chemical method, what are we doing? We are using these polar and non-polar components so that they do not agglomerate with each other. And because of these disturbing forces of cohesion and adhesion, these polar parts don't allow them to agglomerate. What happens? Smaller nuclei of these wax crystals are formed and they remain dispersed within the crude oil. When they do not come together, they do not create a blockage within the pipeline, and hence crude oil could flow easily. Okay. So what we can do, the application of the 4-point depressants, they are cheaper, they can be designed according to the crude oil, and they are used in very less amount such as ppm. We can also check for the various cost of the 4-point depressants as compared to the solvents. It is somewhere around 15,000 for 10 liters and they are applied in 1 ppm. So you can see the economic viability also. Now the 4-point depressants help in keeping the heavier parts of crude oil dissolved or soluble. As you could see, the pipelines runs through thousands of kilometers all over India, and as I said, the crude oil in India is medium waxy in nature. There will always be a presence of at least 10% to more than 15% of wax in Indian crude oil. One more thing, as I said, the flow improvers or the PPD do not have application only in the transportation part. They do work right from the production tubing till storage tank. That means when you are restarting the pipeline, restarting the production tubing after a shutdown. Let's say when the crude oil price have achieved a negative value, as we encountered in recent months, what will happen? Some of the companies would shut down for a while, for months, then they would restart the pipeline, and if it is a waxy crude oil, it will completely block your tubing or your pipeline. Now, while doing so, either you heat the complete pipeline, apply steam into the production tubing, or the second thing is you could use the chemical method. One of it is if you have used the dosage of PPD, it will help you in restarting the pipeline. even after prolonged shutdown. In this way, we can say that the PPDs or the flow improvers, they put less strains on your pump, so they reduce your energy consumption, and they are viable for your economics too, and they reduce your time. In life of a driller, or when you are having a job in midstream, it's very important that you make every second count. So it reduces the time for restarting of pipelines also. So these are the applications of the flow improvers and how it helps in the transportation of waxy crude oil from one place to another. So that is all from my side. Dr. Dhara, now it's up to you, and I hope now we can take the questions.
Yes, thank you, ma'am. Thank you for such a wonderful presentation. It was really informative, especially for us who belong to many other departments and different.
Dr. Vishwas, I would say that I have kept it small intentionally so that we could have more questions from the interdisciplinary fields.
Yes, of course. So I will start with the first question that Dr. Anita Dalai has asked even before we started the presentation. Yes. So her question was waxy crude oil market growth from 2020 till 2025. What are the waxy crude oil market opportunities and threats faced by the vendors in the global waxy crude oil market industry?
Okay. So just for facts, I would say that India is the third largest importer of crude oil, and it is 20th in the production of crude oil. Okay. So, and then when we talk about market of waxy crude oil, I would say that we have, apart from the Middle East part, we have actually produced maximum of the lighter crude oil. And now we are exploiting more of the heavier side of the crude oil or the heavy crude oils. As we discussed during the presentation also, the heavy crude oil constitutes around 40% of the total world oil reserves. So market for waxy crude oil is there. So obviously market for flow improvers is also there. Our demand is not reducing. We are the third largest importer. So importance should be given to flow improvers and how to reduce the energy consumption while transportation.
Okay.
So let it be 2020 to 2025 or further. The need for crude oil and the flow improvers will always be there.
Thank you, ma'am. And a next question from her was, what causes paraffin in oil well?
Paraffin, actually, it is a major component of the crude oil itself. I mean, that is the basic, paraffin and waxes are already present in the crude oil. Crude oil basically consists of carbon and hydrogen, right? 84% carbon and rather hydrogen, sulfur, oxygen, nitrogen and other things. So basic component for crude oil is paraffin is always present there. The thing is, when the temperature goes down, it crystallizes out or it agglomerates.
So we have another question from Anupam Shaha. He's one of our students. He's saying that you are showing a graph of waxy crude oil related with temperature. Please explain the phase transition which occurs here.
Okay. So what happens in this curve is, if you could see the orange part, you could see there are no wax crystals. That doesn't mean, again I am repeating, that doesn't mean paraffin is not present there. Paraffin is a basic constituent of the crude oil. What happens? When the temperature is decreased, the solubility of these paraffin wax decreases. Now these crystals or these wax crystal would come out, and further on lowering the temperature, these paraffin wax agglomerate to each other, or they come together, entangle themselves and create a blockage for the pipe. Also, you could see on the left side or the y-axis, there is viscosity curve. So you can see the viscosity, how drastic change there is right from the original crude oil to the portion where the pour point has reached and below that temperature. So if I would say for Arctic region or colder region, flow improvers play a major part. If you are planning to start a pipeline transporting crude oil.
Okay, thank you, ma'am. Another question from him was for transportation of crude oil, which law is used here, such as Boltzmann transportation law or something else, and how this transportation minimizes the friction or other approaches.
See, these are the fundamental law. Whether it's Boltzmann, okay, whether it's Navier-Stokes. So, what we in petroleum engineering, we derive various models from these law only, and all these law are applied in petroleum engineering. It's not that these are the fundamental ones. So they will always be applied whenever there is a flow.
And we have another question from Rajita Bhattacharya. She is asking, is steady flow maintained throughout the pipeline?
No. The pipeline, in fact, we'll start from the production itself. It's completely unsteady. Usually in production, what we assume while forming models is a pseudo-steady flow. That for the particular period of time, it has been in steady. But it's never steady for a crude oil transportation or production.
So, anybody else who has some question can raise a hand. We can have a discussion or we can write in the chat box.
Can I ask?
Yes, ma'am.
If steady flow is not maintained without motion, then how you calculate the pressure or something like that? You are not using the Bernoulli's equation at that time. I mean, laws of hydrodynamics.
No, we use unsteady state equation. That for petroleum particularly, we have Darcy's law.
Okay.
We follow the Darcy law, and then we find out the pressure difference according to that only. K is equal to K by mu dP by dL.
Because fluid is very, very dense. I mean, it is highly viscous fluid.
Yes.
So there must be some different kind of pressure difference or equation. I think so.
Yes, ma'am. But we don't assume it as a steady flow, and it is never steady throughout. So we take it as a pseudo-steady flow that for a particular period of time, let's say delta T, the flow remains to be steady, and maximum time it is unsteady.
Thank you.
So there are no direct questions. So I will now open this session for discussion. So I would request Aparita Bhattacharya ma'am to take over the discussion.
Ma'am, before that, I just got one question from Bonjita Rovida. She is asking that is there any specific criteria to select flow improver based on the type of crude oil, like heavy, extra heavy, or light crude oil?
Correct. See, let me explain it through a figure. See, if you could see this figure, what I am trying to say is every kind of crude oil requires different type of flow improvers. I said one of the part will crystallize with the wax crystal or will co-crystallize with the wax crystal part. So if you look at the carbon number here in the non-polar part, it should match with that of your crude oil. Only then you can co-crystallize it with the wax crystal. The wax crystal, let's say your paraffin wax is having somewhere carbon number between 322 to 330. Then your flow improvers should also have a non-polar part which have carbon numbers in between this so that it could co-crystallize with the wax crystal. So for every kind of crude oil, the design for flow improvers will change.
Okay, thank you. That will be, I think, wonderful. Now, before I go to Aparajita Madam, I will like to request Dr. Vishnu C. Nair, Dr. Amit Saxena, Dr. Vandita Rovidas. If we will be very happy if they can share their thought or view about this webinar. So first, I would like to request Dr. Vandita Rovidas. Madam, if you can share any view on this webinar.
I couldn't see Dr. Vandita.
Dr. Rovidas, if you can on your video.
Hello, ma'am.
Hello.
Ma'am, actually, I'm just PhD, so right now, not doctor, just Miss Vandita Rovidas.
Okay.
Actually, my PhD topic is related to flow improver for pipeline. So from this presentation, it will really help me in my work. So thank you, ma'am, and thank you for clearing my doubt regarding this the selection of this flow improver through this pipeline based on this types of this crude oil. So thank you, ma'am.
Thank you, Bhumika. In fact, if you are having any other doubts, you can mail me anytime.
Okay, ma'am. Thank you. Sure.
Fine. I think Vito is working. It can help the research level. That is very good feedback for us.
Yes,
And now I will request Dr. Saxena if you could some video on this webinar.
First of all, thank you for the informative presentation, ma'am. And I just have one doubt. Since every crude oil in the industry or available on India is different in nature, so that means you have to design a chemical every time.
Correct.
Every crude oil will have a different composition. So the crude oil design, so you cannot have one PPD for one region. So every time a chemist or a physicist has to go, check, and then develop the chemical. So doesn't it make it more cumbersome to do that job? Because it's say there are 10,000 in India. So 10,000 chemicals to be developed is a very different task.
Okay. So, Dr. Saxena, your doubt is very interesting. My answer would be that it is better to design a chemical which will be used in parts per million than to design a pipeline which would run 100,000 kilometers and then maintaining it at several points, whether the temperature is there, whether there is no leak, whether there is no heat dissipation, that becomes more difficult.
My other doubt would be how to decide dosage. I mean, like it's like crude oil is produced in one part of a country, Gujarat,
Yeah.
and it has to travel to some colder region. Let's suppose Jammu Kashmir. So that means in a hotter region, or you can say in warmer regions, you require a smaller dosage. As the things move on, the wax crystal will crystallize as per your PT diagram, phase transition diagram. The wax crystal will develop. So at that means at every point of time, or you can say after every, say suppose 1,000 kilometers, you need to change dosage, I suppose.
Okay. So,
How does it work?
So, Dr. Saxena, what we do here, let's say your pipeline is going to the least temperature in Jammu Kashmir, right? So, we'll take that temperature as the 4-point standard. That means my pipeline temperature won't go below this. So, I would design a PPD up to the lowest temperature. Let it be JNK, let it be Arctic region, let it be any.
Okay, so you don't have to change it again and again. It's
No, it will just be induced in the starting of the transportation. Then it will work for throughout the pipeline transportation.
so this chemical won't affect the properties of the crude oil.
No, it would, but it's added in parts per million. So it is very less used as compared to, let's say, if you're using a solvent, it will be used in liters. If you're using a PPD, it will be 1 ml for 1,000 liters. So that is the
Okay, it's a very. So thank you so much, and we'll look forward to ask more if it's possible.
Thank you, Doctor.
So much, like the others ask.
Thank you, Dr. Saxena. Now I will request Dr. V to share any thoughts on this webinar. Dr. Nair, are you here?
I've seen messages in chats.
Yeah. Okay. Could you want to share something about this webinar? Okay, I think she just gave us a feedback. That is also wonderful. It is saying that Dr. Shivanjali, thank you for the wonderful presentation, and thank you Department of Physics at the University for the organized. Okay, thank you, sir. So now I will request Professor Aparajita Bhattacharya, Madam, if you conclude our webinar now.
So there is no question. Anyone? No. So I am audible?
Yes,
Yes.
ma'am. Yes.
So no question, then we can conclude and go for the giving the hand to everyone. Apia?
Yes, you can now.
Thank you, Papia. So first of all, my heartfelt thanks to Shivanjali, Dr. Sharma, better say, and exciting and illuminating talk. This is really very, very interesting for us. Particularly this applied field. It is always just, we cannot think how we are doing all these things. So what we actually just read the Bernoulli's theorem in real case, to maintain the flow, to maintain the temperature and everything, it is very, very interesting to know that. So, our thanks from the Department of Physics at University for giving us time at this difficult time. And I also like to thank Dr. Saxena for his very, very active participation and questions.
Thank you so much.
Which actually enlightened us very, very much. Then I will going to thank Pakhara, Assistant Professor of our department, for her tireless effort and work for which make this webinar possible.
Thank you.
Thank you, Papia. Next, our Dean of Science, Mr. Bima Kumar Sarkar. He is an excellent person, enthusiastic, and encourages us in all such academic activity. He left nothing so that we can move forward with our academic activity in this COVID period where we cannot meet ourselves. We are having seminar every alternate day practically. Next, I would like to thank our HOD, Dr. Momita Dev, as she's ever smiling and helping us, leading us from front line, and very enthusiastic. So in our all webinar and everywhere, she is very, very encourages us in all respects. So thank you, Momita.
Thank you, ma'am.
Wonderful leadership. And finally, I'd like to thank all the participants, all the faculty members, all our students, and the participants who are from even outside India, to have attended this webinar, and without whose participation this can never be a successful one. And finally, I just want to mention Apia has offered a virtual coffee with the seminar. Right? We have a real coffee session in our campus. You come to our campus, it is very nice. So,
Yes.
so it is all you are welcome, and thank you all for making the webinar successful.
Thank you so much.
Thank you very much. Thank you very much.
So, sir, you can say something, our Dean of Science
Yes.
and HOD.
Before ending.
Sir,
Before ending it.
Madam, actually, just you given two. So actually, at this moment, I don't know. And really, the Department of Physics as a whole, they're doing the perfect one and in a very right way. And after all, just the professors like you and everybody in the department. So obviously, we will continue to keep the department activity in the right way. So, and really today, the webinar what have been just conducted is really very effective, and in future also will be obviously continuing this type of activity.
From them that those who have already registered will get the certificate.
Yes, registered candidates will get certificates. We will inform by mail.
Okay. Thank you so much.
Thank you all.
Thank you all.
Thank you, Shivanjali. Thank you, me. Thank you all.
Thank you. Visiting the campus. Yeah.
Yes,
Yeah,
for sure.
Thank you, sir.
Okay, sir. Then we can end, I think.
Okay,
for
so
today.
now we can end this session. Thank you very much.
Bye.
Bye. Bye.
Bye everyone.